Okay, so today we are honored to have Vadim Petrochenkov, the expert on the Rust name resolver, join us. And he's going to give us a tour of the code for the Rusty name resolver. Vadim, thank you very much for joining us and welcome.
Welcome, you too.
Can you hear me, Vadim?
Yes.
Okay,
So
it's all yours.
Okay, then I will start. So the majority of code that resolve names in Rust C can be found in the Rust C resolve rate, but it's not all of it, because name resolution happens in many places and at many times. If you can classify the name resolution cases, you can see that there are 4, 3, or even 5 namespaces, type, value, and marker, which are regular namespaces with paths, and also 2 namespaces for lifetimes and for labels, and those 2 are labels are resolved also here in Rust C resolve, but lifetimes are historically resolved somewhere else in Rust C middle. But there is an in progress pull request by Camille Jouer, I think, which moves the lifetime resolution to Rust C resolve 2, because there is no fundamental difference between lifetime resolution and path resolution in lexical scope, at least, because there are still scopes, there are names that are looked up from inside to outside, etc., etc. And together with lifetimes, it will all be in Rust C resolve. And the second large component of name resolution is a type-related resolution, where it's a resolution for type-relative, for associated items. It means either paths with associated items on types, or method calls, which are resolved in a very similar way. And all of that happens in Rust C type check, I think. But I will probably not talk about that now, because that's mostly about type checker. You need first to have a type when you find candidates, and it's generally very different from what happens in Rust C resolve. But it is still a second step of name resolution. Name resolution is Rust C resolve is split into early and late, but the real late name resolution is the type related path. So it's kind of early, middle, and early main pass, and then late pass is type related. So what we can see here in Rust C resolve. Could you open the subdirectory late inside the crate?
I'm sorry, say that again.
The subdirectory named late inside the Rust C resolve SRC. To the left in the file tree.
Here? Oh, here.
Yes, below
late.
SRC late, yes. I see.
And you want this one?
Yes, okay. So the files that we can see here is librs is the main file. It mostly contains data structures that are used for name resolution, both early and the main pass. That's called late here. And some logic that is common for both early and main pass resolution. but not related to diagnostics. Then we have from top to the bottom. Late lifetimes is a lifetime resolution. That's probably. Yes, exactly. Lifetime resolution is already moved to REST resolve. It's just performed after lowering to here and not together with the rest of main path resolution. But and the pull request from Camille is going to move it to the same path, to the same compiler path, not just to the same height. I will not touch the lifetime resolution here because it's very similar to just paths in lexical scope. Access levels is a separate path that access levels errors is a separate path that calculates reachability for different items in the crate. So, for example, some items may be directly reachable with the direct direct path from the crate route. Some items are not directly reachable, but can be named anyway through re-experts, and this path collects the items that can be either directly reachable. This is called accessibility. This access level is actually accessibility, and it should probably call reachability or something like that instead. So access level public is items that are directly reachable, and access level exported are items that are reachable through re-exports, public re-exports. This information is used mostly by RustDoc, but is also used for seeding a later reachability path that also collects items that are reachable through types. So, for example, if a function returns some type that cannot be named, the types still become reachable. This set of reachable types is important because a lot of things are actually based on this reachable set. For example, a set of symbols that are visible from the compiled binary is based on this reachable set, and links like missing documentation and what else? Missing instability attributes. They are all based on this reachable set because it's a set of items that are somehow public and visible to outside of the crate. So the initial set is collected here in resolve. It collects public and exported. This path is just separate from the rest of memory resolution and independent from it. So we can move to the next file called build reduced graph.
Which one is it?
The next file, build reduced graph. How to say it? This logic in this file is responsible for planting expanded items into IST. So during expansion, the AST is not ready yet. It is built gradually during the expansion process. So when something is expanded and takes it to its final form, then that item is planted into the IST, inserted into the IST, and it is also visited to find next macro expansions in it. So this large pass is responsible for inserting items into AST basically. That also includes not only IST but some kind of IST-like structures for other crates. You can see a lot of code about modules here, and module is some kind of container for names that are built during early name resolution and together with HT, and they are built for external crates too. But for external crates, they're built lazily, so only what is necessary built. So this whole file is about that, about inserting things in into AST and visiting them in search of new macro invocations. On the screen, you can see resolve visibility. It is done here because visibility is something that you have to resolve very early, because you cannot insert item into a module without knowing its visibility, because it will affect for resolution. We can probably go through the code in style later, and now let's just go through all the files and go to the next file, check unused. This is also a separate isolated class that is responsible for finding used items that are if no path refers to some item, then it is reported here. In most cases, in cases of traits, it is reported by later pass because traits can be brought in scope but used later through method calls or something like that. But majority of unused items are reported here. It's not very large pass. And like half of this file is responsible for finding a proper span for the suggestion. The next file is definition collector. It is actually a part of build reduce graph, especially. It is also run as a part of when you insert some expanded item into AST, def collector also runs on it and finds the macro invocation in it and builds this thing called def path data. It means definition paths. This is a stable representation of definition IDs. So these def paths that are used mostly for incremental compilation to represent items in a stable way between grades. They are all assigned here as a part of a build reduced graph class. Then we can see the next file called Diagnostics. It's a huge file. Uh, it collects all kinds of all kinds of diagnostic logics. I try not to look into this place because the huge garbage dump.
It is a really big file.
Yes, yes, it's not just big, it just contains a lot of heuristics and basically a huge barrier for any kinds of refactorings or attempts to turn name resolution into library. So if you have to, if you need to refactor anything, then you will have to refactor this code as well. But it's a daunting task. Okay, we probably don't need to look at this anymore. Then this is this very old file actually, and it performs import resolution. And I don't remember what code exactly is here. Yes, probably something import specific and something specific to early resolution, because, for example, yes, what this code on the screen, it is used by not by imports, but by any kind of resolution that happens during macro expansion. We will probably need to talk about this in more detail later. Now we can skip to the next file. Let's go later is. And this is also an isolated pass but it's a large pass. It performs most of name resolution. Some paths like imports or macro paths need to be resolved early to perform macro expansion, etc. But the majority of names, like names in expressions, types, or patterns, they can be resolved altogether when AST is already ready and there is no uncertainty, and we can just go through paths and resolve everything. Unlike with early resolution, when we have to go through some complex iterative process that involves both expansion and name resolution. Here we just go through the IST, which is ready, and just resolve paths. But it's still a large task, and there is a lot of logic here due to diagnostics as well. For example, huge structures like this, like slightly above. Okay, we missed it, but it was about diagnostics, so sure, it probably needs to be moved to the diagnostics area. Okay, but the majority of this file is just this large pass that simply resolves paths. And the last file in this directory is macros rs, which is kind of similar to imports rs, but it's all about macro specifics. And yes, that's all about resolving macro paths and also loading macros from metadata and also calling macro compilation from the CX1. So yes, we can see here some expanding some specific macros like CFG accessible, and we also see some diagnostics logic here. But it's mostly about macros, as the name suggests. I think now we can go through some specific code, unless you have questions.
Does anybody have any questions at this point? Olivia, unmute yourself.
Thank you. Yes, I have a question, but it was a bit too long to type, so I prefer to speak. Thank you so much for that, Vadim. That was super, super useful. So I have a question that is kind of more general, like trying to understand a little bit the sequence of things and how it works, because you mentioned diagnostics a lot. So I'm just thinking, if you have a case where you have, like, you're trying to use this type A and type B, but they don't exist, right? So they will never be resolved. How does it work from the sequencing of things? Like once you find, oh, A is actually, A cannot be resolved. Like, do you keep going and kind of gather all the errors and then you like send all the errors to diagnostics, or are there some cases in which you stop and you like stop processing?
If you have a path, for example, in type position that cannot be resolved, then we try to resolve it in different ways. For example, in different namespaces, try to find type of candidates among names in scope and apply all kinds of heuristics and try to find this name and similar names. And if we find something very likely, then we just substitute resolution for that likely resolution and use it. And if we really cannot find anything, then we just have this thing called resolution error. We can see it on the screen, at the top of the screen, res error. And we return it as a resolution. So it means we cannot do anything. We cannot find anything. We just return this error. And later on, during later compilation, this resolution error is just used to silence all derived errors from type checking, etc., etc., etc.
That makes sense. Thank you so much.
The exact place where it happens, maybe you can find the function called smart resolve path. It's somewhere in the grade, but I don't remember where it is exactly.
Okay, where would you like to go next?
Maybe in Liberas. Could you find a function that is called smart resolve path?
Smart resolve?
Yes, smart resolve. So,
Oh, let's see here. Seems to be in late.rs. Yeah, I have a new machine here, so pardon me. Let's see. Late. And I'm not sure how to do find on this machine. Oh, there it is. Okay, there we go.
so we need smart resolve of fragment instead. Just below.
Fragment?
Yes. So we have a path that we want to resolve. Span of that path the path source is an enumeration that tells us what context this path came from, and some node ID for lints, and the create lint thinks it's something about compatibility between editions. I don't remember exactly. So what we do here, we could you scroll? Oh,
Go to the top.
yes, with some report errors, closures. No. Below.
Not that far.
That's too much. Could you return to this smart resolve function? Now we one screen below. Into a different other direction.
This way.
Yes. Could you scroll? I will tell when it needs to stop. Here we can see error reporting functions, another error reporting functions. We need to go further. One more. And only here we can see the main logic. We call the resolve queue path anywhere. That means we are trying to resolve the name in all namespaces, in type namespace, value namespace, and the macro namespace. And everything below is also mostly diagnostics, or attempts to defer name resolution to type checking and perform it as a type related name resolution. And in the end, we get the resolution, record it, and return it. That's so it's kind of the name resolution, like it is done in the language, is wrapped in a few layers of fallbacks and attempts to resolve it slightly differently to improve diagnostics. So I would say majority of code in RC resolve is actually about the diagnostics at this point.
Any more questions? Nope. Okay. Vadim, where would you like to go next?
Can we go to Liberas now? So now I will just try to describe what I see on the screen. We need to go from the top of the file. Okay, we don't need the imports. What we can see here. What is determinacy? I will then describe the data structures and enumeration. Determinacy means when we are doing name resolution during macro expansion, we see some items in AST, but not all of them. Some items can appear later during expansion. So could you freeze the screen and not scroll further? Okay. So when we are resolving some macro path or import path, we may get no resolution, but that doesn't mean there is no resolution, because some resolution may appear later if there are some unexpanded macros, etc. So then resolution functions at this point return results, and in case of errors, no resolution, they also return determinacy. So the determinate error is means that we cannot find the resolution, and such resolution cannot appear later. And undetermined error means that we cannot find the resolution right now, but it may appear later when some macros are expanded. So the next enumeration we can see here is scope. This is the set of places where names are looked up during resolution. For example, when we try to find something in type namespace, we go through one subset of the scopes, like module, then external prelude, to prelude, a standard library prelude, and then through built-in types. And when we are resolving macros, then we go through a different subset of scopes, like two kinds of derived helpers, macro rules, module again, then macro use prelude, regular standard library prelude, and registered attributes and built-in attributes. So it's just a set of places that we need to search names in. And below we have a scope set that describes a subset of these names. For example, scope set all namespace is a subset for certain namespace, and scope set macro is the same thing as scope set all for macro namespace, but we also have a restriction on macro kind. For example, when we are searching for function-like macros, we ignore all attribute macros in scope due to backward compatibility. Because when macros were modularized, there were a lot of conflicts, like you have a macro called ignore, and you have a built-in attribute called ignore, and now you have a conflict, and you have some code that worked before now breaks. So we have to introduce this kind of subname space into subname spaces in macro namespace. And when we are resolving a macro path, we have to also take the kind of that macro into. And one scope set for late resolution, and kind of the parent scope set and describes it is a location for a name. Location contains location of a name contains all the data that is necessary to resolve this name. So if we know the module in which this name is located, then expansion ID of the macro that produced this code, the current chain of macro rules, and also the list of legacy derived helpers in scope, then we can resolve any name. But this doesn't apply to late resolution because it's not unified yet. But it is enough to resolve most of names. So this kind of identify the location, the name in a unique way. Then we can go through the next enumeration incorporate context. I don't remember what is this exactly. Okay, yes. Infiltrate is treated differently in argument position and return position, and the name resolver also needs to do something differently in this case because the def paths, definition paths are different in this case. Because name resolver creates definition paths, it also need to know about this context. Binding error is something about diagnostics. Okay. This enumeration is many kinds of resolution errors that name resolver can report. They are not resolved right away, but return does this enumeration instead and reported in a single place. We can go for this is a separate enumeration for errors in visibility paths, just because visibility paths have to be resolved very early, so they have to have a separate enumeration for errors. But maybe that's unnecessary. I don't know. I don't remember. Segment is a segment in a path because path can contain multiple segments, and each of these segments need to be resolved. And each of these segments have an identifier and also node ID now. We can go over. This is some diagnostics again. This codes find places for suggestions. We can skip it. And we can skip this too. No. Slightly. Okay. And this lexical scope binding enumeration, it's the same thing as name binding, but it's an optimization. The result of path resolution for something that may be a local variable. Such result is lexical scope binding, because we tried to create full name bindings for everything, including local variables, but it was too expensive because there's a lot of local variables, and instead of creating a full name binding, we just create some minimal necessary information like the rest enumeration. So this is just an optimization over name binding. We can go look for. This is also an interesting enumeration. But that's too long to explain. It's about okay, I will skip it, but this is interesting, but it's long to explain. Another enumeration for results of of the main resolution pass that is performed in later S. And this enumeration can probably be unified with something else. It's just nobody had time to do that. I think a lot of things here can actually be simplified to just not enough people with enough time and expertise to do that. Module kind is what is a module in the name resolution? It's any container for names, container for items. So it's not like a module item in the language. Module in name resolution sense is can be either a regular module, but it also can be a block inside the function because it also can contain items, and it also be an enumeration and also a trait. So this module kind makes a distinction between modules, item level modules like module items, enumerations and tries, and block items and block modules inside functions that are just curly braces. Oh, this is some very technical details. It's not interesting. Module data is just all the information about module that's necessary for the resolver. The type module below, it's a reference type, and the module data, it lives on in some arena. There is an arena that is used by resolver, and that arena is allocated before the resolver is created, and a lot of data in resolver leaves that arena, including data for modules. This is kind of similar to the arena for high-level internal representation and maybe for AST in the future. So some data that lives while the resolver is alive or while here is alive, and it can be dropped after resolver or here are no longer necessary. Here we can see some utility functions, especially interesting. Here's some interesting part. Name binding. We have talked about modules before. Module is a container for names, and name binding is any name in that container. So when we resolve some path, the result is this name binding, and also modules contain name bindings. Name binding is an information about the definition, the macro expansion that produced this name, its visibility, and also name binding kind that determines whether it's import or a proper item. So these bindings populate modules which are containers for names. Again, some enumeration for the diagnostics. Again, some diagnostics. Some utility functions and helper methods. some small data structures for external crates passed through command line, and for external crates, external crate item. And here we see the main structure, the resolver. It's a huge data structure that is used for everything. So during late compilation, when we lower AST to here to HIR, then we have a huge global context called TCX, type shaping context, and this is basically an equivalent of TCX, but before the TCX is constructed. It is the global context that exists starting from macro expansion and ending with construction of the next global context, aka T6. So we have lots of data here. Some are used during name resolution, and some are just results that are passed to later passed. Here you can see the arenas that are used for allocating all kinds of resolver data. This is a resolver functionality that's used by HIR by lowering from AST to HIR. Mostly about retrieving resolutions for nodes. Construction method for this global context. This is an important function that kind of destroys this global context resolver and collect data passed to the next global context, P6. This is called resolver outputs. So this function collects all the resolver outputs from the resolver. This function is an entry result rate. Could you stop for a second? Yes, here. This function result rate is an entry point for the whole late resolution pass or main resolution pass. So if you want to see what happens after the expansion is done, and we need to resolve remaining names, you can start from here. These are some functions for connecting traits in scope, because type-related resolution uses sets of trait in scope to resolve methods and also type-related paths too. So we need to collect some trait in scope here and then save it for later for type check. Here's some utility functions again. This function is also important. It's a generic scope visitor. It's a visitor that walks through all the scopes and does something. It is the main use is to go through scopes to actually resolve names, but there are also a couple of uses for diagnostics. For example, for collecting suggestions for typos. So we go through all the scopes again, but we don't just collect resolutions. We collect something else like possible candidates. This function is a place to see of a resolution algorithm, which names have priorities other compared to other names, etc. So the main name search algorithm is here in scopes. Here we can a couple of screens above. We can see some functions related to macros, to macro hygiene, but including some compatibility measures, but we should probably look at them now. And below we can see logic for finding names in modules in name container, our name containers, which is complicated by two things: hygiene and indeterminacy when we are resolving names during expansion that AST is not completed. So some logic here and below is about that. Entry point for resolving paths. Entry point for late resolution that includes all of the variables. And some of the diagnostic logic is also mixed together with the main part of the code. It should probably be moved to a diagnostic service. There's some utility functions. Some diagnostics again. Some other diagnostics. More diagnostics. Something for us doc. This logic is only used by RSDoc for resolving documentation links. and again some utility and some not very important. Okay, that's the mine file. File. Ideally, some logic should be probably moved from here, at least if it is related to diagnostics or maybe to resolution as well, and only data structures to be left here. But we have what we have. Maybe we probably have time for one more file. Which one should we look at? Something
I
about
think Olivia
market?
has I think Olivia has a question.
Oh yes, maybe if you have a question.
Oh yeah, sorry. My question was, are the tests for name, like, are there name resolver specific tests, and are they in some different folder?
There are no unit tests for this, only integration tests in the big test directory in SRC tests.
I see.
So
Okay.
all the solver testing is done through integration tests.
Not a question, but you mentioned at the start of the presentation, accessible. Can you tell us more about how it will work from the context of the resolver?
Yes, you can. Could you search for CFG accessible in the crate? Because I don't remember where exactly is the code. Maybe in macros, maybe somewhere else.
Is it in librs?
Probably not librs, probably somewhere else.
Okay. Where would you like to check?
Macros, for example. We need to find CFG accessible here. No. Underscore. CFG underscore accessible. Here it is. So this is a public interface that resolver have. Right now we have we don't have a CFG accessible as a part of CFG. We have a separate attribute macro called CFG underscore accessible that performs this functionality, and it is partially implemented, but not entirely. So the definition of this macro is in a different crate called RASC built-in macros, but it mostly verifies its input and then it calls this method from the resolver. But it is incomplete. What happens here is that we CFG accessible attempts to find the path resolution in all namespaces. So here we are going through all namespaces and try to call resolve path. And if the resolution is success, we can return true. CFG accessible is true. This is either path result module or path result non-module cases. If the result is indeterminate, then we can return an indeterminate error, because CFG accessible can also be used during macro expansion, so it may return false. so the name is not found, but the name may be found later. And we have some support for indeterminacy in our macro expansion system. So if the macro returns an indeterminate result, then that macro expansion is returned into the macro queue, and we'll attempt to expand it sometime later. And maybe later we will be able to give a determinate result. But now you can see fix me here. If resolve path returns failed resolution, it yes. So resolve path isn't exactly suitable for this. It misses some, doesn't return complete functionality. So if the name is not found, we cannot return false, and the resolve path needs to be modified and updated to return the correct result for not correct but usable result for paths that may be type related. So this is the case where we cannot rely on the result of resolve path, and we just report a completion error. This is why the implementation of CSG accessible is not complete. Someone needs to modify resolve path to return a result that is have more information in case of unsuccessful resolution.
Are there any more questions? No?
I do have a bunch of questions, but they probably can wait for the end. It's not really specific to this fight or something like that.
We only have 15 minutes, so it's
Okay.
probably already
Okay.
the end.
Yeah.
Okay.
Yeah.
So let's go. First of all, Vadim, thanks. That was great. Very informative and very helpful. I do have a bunch of questions. I don't remember the order of things, like why did we have both early and late resolution? Was it because the expansion was somewhere in the middle of between these two?
So the early resolution, it happens together with expansion. So
Okay.
we attempt to expand something when we try to resolve things in the output of that expansion. When we try to found expansions again, we can find new macros, resolve them, expand them again, found more macros. So it is an iterative process. And early resolution is a resolution of macro paths and import paths that has to be performed during this iterative process of expanding macros and discovering new macros. And a late resolution is simply everything else that doesn't need to be performed early and can be performed altogether as a single pass on the IST when the IST is complete.
Okay, thanks. That's clear. At a few points you mentioned some things about diagnostics that were actually in librs rather than the correct file. So in the same vein, I was wondering what kind of cleanups, documentation additions, maybe some fixes or refactors do you think new contributors could tackle here? Like just moving the things from the libs to the diagnostics file seems easy enough. So maybe some of us could do that. And
yes, that's a good start. Moving
Yep.
something diagnostic related from librs to
Yep.
diagnostics RS.
And do you have maybe other ideas that new contributors would tackle? I'm not sure if the resolver is especially a great entry point, a great simple entry point for new contributors, but if they are easy tasks,
New contributors usually do
yeah,
not clean up things, but work in the opposite direction.
yeah,
I'm, I don't know, maybe I don't have a specific suggestions. Usually
okay,
people just read the code, just try to
to
refactor
clean up,
something.
yeah, sure.
Yes, and the cleanup naturally happens
So
when you
if
know the
you
code well enough.
if you have ideas sometime, just let us know. I believe like a bunch of members here would like to have some contributions, and so if there are easy issues, like we can walk through them. We can walk them through opening a PR and things like this.
Oh yes, I don't exactly remember
Yep,
most of the code here.
for sure.
So to find something to refactor, I need to read the code
Yeah, yeah,
again,
read again,
and
of course.
then it's faster to just refactor it myself.
Yeah, that's true as well. Very common. In the same vein, I was wondering, do you have plans? Like I know you've been working on some refactoring for Rustdoc, like because it clones the resolver or things like that. So I was wondering if you yourself had future plans about tasks to be done about for the resolver besides this Rustdoc one.
Yes, I have a pretty large queue of tasks, but uh, I'm unlikely to ever get to them because there are always more tasks with higher priority.
Yeah.
Yes, maybe I will extract resolver related tasks, some smaller list and post them into the Zulip thread.
Okay,
But
interesting.
they are not filed as a proper issues. It's just some short sentence like do something, and the description is for me, not for
Yeah.
anyone else. I will have to turn them into proper issues for them to be actionable by anyone else.
Yeah. I was wondering, like, how, like, is the resolver actually involved in incremental compilation today, or not?
Not, no, not.
Okay. Do
It
you think
happens before AST is
before?
lowered to
Yeah. Okay.
HIR and incremental starts from HIR.
Okay. And
HIR is hashed, and now maybe with recent work, the AST just before it is lowered is also hashed. And the next step is um, to expand the incremental compilation to late resolver.
okay.
That's what Camille wanted to
Yeah.
do next year,
Yeah.
if everything goes according to the plan.
Yeah. Depending on what we end up doing with the incremental compilation system.
Yes, well, that too.
And I was wondering, like, how fast is the whole resolving process since it's interleaved with expansion? I'm not sure if it's easy to pull apart, or did you ever find some benchmarks that where the resolving itself was slow, maybe on huge crates? I'm not sure if we really have a lot of benchmark that exercise it very much, but
Maybe resolve is usually not a bottleneck.
yeah,
That's why I didn't see people uh, benchmarking it carefully. I mostly paid attention to functional correctness, and I didn't benchmark it myself because it usually wasn't a problem in practice.
yeah,
One bottleneck was about derived resolution. People from Microsoft, which implement Windows REST rate. They
I
had
remember, yeah,
a lot of derives in a single file, and it triggered some, not sure, maybe even exponential effects. And that was a serious issue that was encountered in practice, and it was fixed after someone else benchmarked it. But I didn't didn't try to do any benchmarking myself.
Yeah, and to be fair, their crate is like completely huge for all the Windows API bindings, so it's not really representative of real, like most crates that people actually use.
Oh, that derived related improvement, it actually had effect on other
Ah,
crates
interesting. Yeah,
and
interesting.
the perf benchmarks.
And so
Maybe
in this,
not as drastic as for
yeah,
the derived extracted from Windows servers, but maybe 5% on crates like, I don't remember exactly, some large crates like maybe Clapper's or maybe something like crates from Zero or something like
yeah.
that.
In the same vein, so do you, like, this seems hard to parallelize? Like, do you have thoughts about whether it would be interesting to try to make the resolver more parallel, or
Late resolver, I think it can be made parallel because
is it per file, or per module maybe?
it is per module because
Yeah, we can easily do that. Yeah.
yes, because if there are modules are isolated from each other, and if you resolve a name in some module, the set of candidates, it is also all of the candidates are either in this module or fixed before the late compilation starts, like macro rules,
Yeah.
or it's some global names from Prelude that are also should be fixed before late resolution. So I think during late resolution, modules can be processed in parallel.
Yeah, for early and since it involves expansion and accesses to some shared data structures is going to be way harder and probably not that useful, maybe.
Sorry, do you mean for early resolution or for?
Yeah, for the earlier parts, yeah. So it's probably going to be harder because
For
with
earlier parts,
the share.
there's some long distance effects.
Okay.
Changes in other modules can affect imports. This module, macro rules can appear and change resolutions in the whole crate and something like that. So it's also an iterative process. So it's probably very hard to parallelize.
Yeah, going to be accessing shared data structures and mutating them and locking and things like that.
Yes, even during late resolution, some caches like external modules may be populated. So even for late resolution, maybe some locking may be needed, but it's mostly for cache-like structure.
Okay. Okay, great. That's it. That's it for all my questions. Thanks a lot.
And now the time is almost over. We have 3 minutes.
Remy, that was amazing. Thank you. that was a great set of questions.
You're welcome.
Thank you for listening.
Yes. Does anybody else have any questions for Vadim? It's such a treat to have him here. So if you have any questions, don't hold back. Yeah, you can unmute and say that out loud, Olivia. I think
Yeah, of course. I just wanted to say thank you so much, Vadim. This was super, super helpful. And I just wanted to re-emphasize what Remy said. Like, I think some of us would be really keen to contribute, myself included. So if you have time to put those issues down, and I know probably it will take you more time to write everything down than it would take you to actually fix it. But in the spirit of having more people learning about name resolver and contributing, I think that would be cool. Yeah, thanks again.
I would have more interest in reviewing something that is already ready than in, for example, producing issues. So if you can come up with something myself, I will gladly review it. But about making issues, I'm not sure I will do it, but I will try.
No, that makes sense. That makes sense.
Yeah, so Olivia, just to speak to that, we are revamping the Rusty Reading Club. And so there will likely be additional sessions on the name resolver to help people get to the point where they are, where they can contribute. So stay tuned. We have a couple of things to finish kind of on the back end, like the write-up and the consulting with the compiler team. So I would say probably look for something in April. And also I usually update everything that we're doing once we're ready on my blog. So I have a blog on Medium. I probably should post the link to that somewhere in the Zulip stream. Okay. Vadim, thank you so much. It was wonderful of you to make time for us while you're on vacation. I don't know if everybody knows that you're on vacation, but so thank you very much for taking the time. This was super.
Yes, thank you.
All right. Thanks, everyone.
Bye.
Bye.